So AmeriLink, and here are some of the types of data that AmeriLink has. I think this is per your book. This is how many millions of people they have the data for. Age and income, 236 million people, whether there's an auto loan. They have census data, dwelling type, 236 million, gender, glasses wearers, 19 million, height, weight, 55 million, home ownership, 153 million, house value, 123 million, length of residence, mail order buyer, 108 million. Well, that's always a good one. People always like to know you bought things through the mail. Nonprofit donor, persons in household, occupation, religion. Do you have a student loan? Wealth, 236 million. So a lot of data there from AmeriLink. Some of the information that's available. Okay, let me just make sure I can, there we go. Okay, so geographic data can also be added, previous purchase history. Okay, that's my favorite, that's the gerrymander districts in, I want to say, Winston-Salem, North Carolina. Okay, so this is doing a test to create a model. This is how you go about starting to do some predictive modeling. So to find the right people who respond. So you got your test group of 12,250 non-responders, 250 responders, and a validation group, 12,250 non-responders and 250 responders. Both groups, same type and variety of people. So you're doing a matched, test and control. The model development process works with the test group. Okay. So, and good old multivariate analyses are used here. So the dependent variable in the purchase is the purchase that the customer made as a result of the promotion. 500 bought and 24,500 did not. That's the 2%. The independent variables are behavior and appended data listed above. Which of the independent variables will be most valuable in predicting who will buy and who will not buy? And that's what the model is designed to find out. And you do your multivariate analysis. And here's our good old example, which we've used a lot of times. And a lot of you actually remembered this on your midterm. So we are doing the analysis, and we're finding out which of the, the characteristics back here. Way back here, yes. Right, dwelling type, who knows what, all these things, plus purchase behavior. So all these things, we don't want just a list of, in other words, a flat list of criteria that people who respond have in common. Okay, we're looking for a weighting, because there might be 20 different criteria they have in common. You don't know. You can't give them all equal weight. You need to find out how much each factor contributes so that you can really do some fine tuning. Okay. And this is actually an example of a multivariate analysis. Okay, so here are on the left a listing of things that you know about each responder versus non-responder, and you can see all these things. A lot of them are, did you dial up to register? Did you pay by credit card? What was your first product you bought? What was the amount of the last item you bought? Sale, first pay method, credit card. So this is a lot of transactional data here, more than I would say demographic data, at least in this example. It could have been demographic data too. And when you do the multivariate analysis, you find that some things have a negative, some of these things have a negative contribution. Like the first three, you see the effect, is it negative or positive? And then you see how much negative and how much positive each one is, which is the percentage in the contribution column. See, it adds up to 100% at the bottom. And then you have a coefficient. So the coefficient is, you're able to apply now to each one of these variables to come up with an equation, basically, to help you predict each customer's behavior. Each customer's behavior. Okay, so this says, for instance, let's see, sales item amount, $0 to $100. It's a negative 12.72%. Last registration recencies, positive, so 7.9%. So these are listed in order of percentage, or in order of the magnitude of their contribution to responding to the promotion. So, okay, so I hope you understand that. Okay. Could ignore variables whose weight's very low. Okay. So instead of using 30 different variables, you can build your model based on the 5 or 6 variables that provide the greatest predictive power. Save you money later on when you have to append data to a large file so it can be scored using the model. You'll only look at 6 variables rather than 30 variables. It's a lot less computation time and a lot less space. So the final outcome of the model is an algorithm, a mathematical routine used to perform computations, which will be made up of the coefficients for different independent variables. Now, this is a little talk about dashboards, and you had some experience with dashboards with your work with Access, where you created dashboards. That was part of the assignment. So this is the idea of starting to set up a tracking system within your company to keep track of various events / activities. You can see these are some ideas of things that a company might want to keep track of. Emails sent and delivered, percentage of delivered emails that are opened, yes. The open rate. Clicks compared to other campaigns, yes. Percentage of opens that are clicked, so the click-through rate, right? Churn rate, people unsubscribe or undeliverable. Viral rate, if the emails are sent to a friend. Opens and clicks by domain name, interesting. May also include, some of these things. Total sales by certain time periods, by the campaign, by the month, the quarter, the segment, whatever. Profit per email, sales per email, cost per email, average order value, number of orders, conversion rate of opens or click-throughs, number of site visits, cost per visitor, number of leads. You can see this all makes sense, right? By entry page, length of site visit by source, average page views. So basically, you would be using the software program, a dashboard creating program, to set up automatic tracking of these. You'd be pulling this information directly from the database, particularly the transactional database. And so, anytime I went on this dashboard, I would get updated new information on things. Okay, so this would be like a corporate dashboard senior management will be able to go to and keep an eye on things. A number of leads, this would probably be more like B2B, maybe number of downloads, site visits. Google PageRank's a good one, yep. Cost per lead, conversion rate. Membership, subscriber, or database growth, yep. Number of new customers, cost per new customer, things like that. Okay, this is from your book. I just lifted up like the last page in this chapter. So analytics, predictive modeling can help you predict which recipients of your direct mail buy your products, which are not likely to buy. At $500 per 1,000 pieces, analytics can save you a lot of money. This is if you're doing mail, right? Analytics, to say, is not as used for email marketing. The cost of appending data and modeling often results in a loss, since the cost of mailing is only $6 per 1,000. Well, I don't know. I think you can do some segmenting. Certainly doesn't hurt to do some segmenting with direct mail. So this is, not sure I have in total agreement with that one by our esteemed author. Predictive models are based on previous promotions. You add demographics, etc., to a sample and determine the differences between responders and non-responders by our world-famous multivariate analysis. Predictive modeling uses multiple regressions. It results in an algorithm. It can be used to score any direct marketing file, meaning list of people that has demographics appended, and predict before you mail which ones are going to respond. So nice piece on predictive modeling in your book. I'm going to stop here, and then on the other side, we're going to start to talk about kind of putting together the format, the architecture of a database, which is called database modeling.